All right, everyone, welcome back to another Python video. Here we're going to be solving two questions. The first question is words to lengths relationship, where we're going to be pairing each string with their length in a dictionary so that each word will be their key address, and we're going to have their length as their value. In the second question, we're going to be revisiting the Fibonacci dictionary, Fibonacci sequence, and creating a dictionary out of it so that we can get something like this, where you can have the key acting as the nth pair, and then we can have the values grown from those two starting points. So let's get started with their words to length relationship. So we can say word length function. We're going to create a list. And we're going to just be assuming that a list contains strings. Okay. So what I'm going to show you is a long way of doing this. We could say that this is a empty dictionary. And we can go for word and a list. We can say that result at this word is going to be set to or equal to the length of the word. And then we can now return result. Okay. So this is just a fully like a very systematic way to do and create a dictionary here. We're gonna write four lines of code, and it's gonna be working as intended. So to see that, we can say word length of this just to show you how that would run. Right. So let's test it with Python video 46 pi, and we get our intended output of apple having 5, banana having 6, cherry having 6, and date having 4. All right. So with that said, I want to make this a little shorter. Right. And this is where this dictionary comprehension come into play. Using dictionary comprehension, where it is going to do the same thing, but we're going to just write it in a single line because this task is relatively simple. So we're going to say we're going to be returning a dictionary. So I'm going to draw a dictionary here, or write a dictionary like an empty dictionary. Now I need to define how my dictionary would look like. Okay, so I'm going to have some sort of a key. Okay, and then that's going to be assigned to, well, my length of key. Okay, so I'm going to have this variable that is called key, and the value at that key is just going to be the length of that key. Okay, well, where did that key come from? We can say that for key in a list. Now, keys now is just going to represent each individual word or string that is inside our a list, right? So we can say that in our dictionary, for all the keys that are in our a list, that's going to act as a key, and we're going to assign it with the length of key. And if I run this single line of code, we're going to get the exact same behavior. We have just shrunk this, and we lost the need for a temporary variable that's going to store our resulting dictionary. So this kind of action is called a dictionary comprehension, and you can do this with lists and sets, where we get to speed up some of the easier dictionaries or data structures that you get to create by doing a single line comprehension. So that is a handy tool that you can have in your Python toolbox. Okay. Now let's revisit our Fibonacci dictionary. Okay, we're going to create a function that returns a dictionary given an integer argument. We're going to store all the nth values as a key and nth values within the key's location. So let's get started. So we're going to call this a dfib for dictionary Fibonacci number, and we're going to have a number. Okay. And we can say that our result is just set and initialized to the key of 0 having the 0 value, and the first Fibonacci number being 1, and we will be creating all our Fibonacci numbers based on this. Okay, and we can say that, well, if a num is in result already, as in that is already a key, well, we can just return the result. Okay, because we have calculated the 0th fib, and we have calculated the first fib that already acts or is within our list of keys in our result dictionary, so we can just return our result. But if not, what we can do is, well, for I in range starting at 2, we're going to go up to num plus 1. Okay, and we're going to say that, well, our result at this new I value, which is going to act as a new key that we're going to add starting from 2, is equal to taking the value at I minus 1 plus result at I minus 2. Okay, so we're taking this value and this value, and that is the fundamental Fibonacci sequence calculation, where the next value is a result of two numbers prior from our series. Okay, and after this for loop is done, we get to now return our result dictionary, and that's the end of the fib. And let's see what happens if I were to say print the result of the fib. If I were to get all the numbers from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, even the 10th Fibonacci number, starting with 0 being 0 and 1 being 1. So if I were to run that code, we know that at 10, we get this Fibonacci value of 55. And this dictionary is now able to track at which nth location, which Fibonacci numbers we would get. So this is another way to solve this problem, which we have done many times. And we will actually do this for the one last time when we do talk about recursion as well, because Fibonacci is very recursive in nature. So in the first question, we were able to do dictionary comprehension to create a very quick dictionary if we wanted to, and we just returned that from a function. From our second solution, what we were able to do is just revisit the Fibonacci series and store that n to the actual number of the Fibonacci number at that n location relationship and store that in a dictionary. Okay, so that was both of our solutions. Make sure to read over the solutions that I do upload. But regardless, thank you for watching and stay classy.